Hi there, good morning. So last time we're able to discuss some introduction to carbohydrates. So in our discussion, napag-usapan na natin yung definition ng carbohydrates being a polyhydroxy, aldehydes, and ketones. So dapat ay familiar na kayo doon sa structure ng aldehyde at ng isang ketone. Also, we also discussed the functions of your carbohydrates. We classified your carbohydrates into four, like monosaccharide, disaccharide, oligosaccharide, or polysaccharide, depending on the number of the constituent, kung ilan yung monomer units ng ating carbohydrates. We also did uh, classification of monosaccharide based on the functional group. So we have an aldose and a ketose. So aldose having an aldehyde group. So in the terminal carbon dito natin ay aldehyde yung kanyang functional group. And then we have a ketose if we have a C double bond O in the second carbon position. We also have this general formula that is applicable only for monosaccharides with 3 to 8 carbons only. So that will only work if you have 3 to 8 monosaccharides. We also did a classification of carbohydrates based on the carbon atoms. We have triose, tetrose, pentose, hexose, heptose, and octose for carbohydrates, or specifically monosaccharides having a 3, a 4, 5, 6, and 7, and 8 carbon atoms. Also, we classify this sugars, and we merge the information. So it's an aldo tetrose, it's a keto triose. So meaning an aldotetrose has an aldehyde group in the terminal carbon, and then it is made up of four carbons for an aldotetrose. So we also talk about stereoisomerism, which one are optically active. So only one is not optically active, that is your dihydroxyacetone, because of the presence of a C double bond O. Okay? And glyceraldehyde is the simplest sugar natin, simplest monosaccharide having three carbon atoms. So we also talk about Fisher projection formulas, the ones that you are usually nakikita nyo dito. So we also have the discussion of D sugars rather, and L sugars. Both are enantiomers. So when you say D, your OH group is on the right, and we're talking about, or we're pertaining to the penultimate carbon. So if the OH in the penultimate carbon is in the right, then you assign it a D configuration. Or when we have an OH group in the penultimate carbon situated in the left, then you have an L sugar. Okay? So you should remember it's the penultimate carbon, the second to the last. If this is the last carbon, then this one is your penultimate carbon. And only D sugars are naturally occurring. So we also have the discussion of anomeric carbon. So the anomeric carbon is the carbon in the C double bond O. Penultimate carbon is the second to the last carbon. So we also assigned the stereoisomer configuration of our monosaccharides by simply looking at the last, or the second to the last carbon natin. We call that your penultimate carbon, and deduce the configuration based on the position of this OH. Since this is on the right, then you assign this as a D. Okay, and then we already determined that this one is a aldotetrose. On the other hand, this one naman is on the left. The OH group is in the left in the penultimate carbon. Then we assign this as an L. And then This is an aldohexose because this CHO here is just a simplification of this C double bond OH. Yan, CHO lang din naman yan. They are the same in structure. And then we determine that this is 6 carbon long, so that means this is an L-aldohexose. So for the determination of possible structures natin, yung stereoisomers natin, we use the formula 2 raised to n. So where n is the number of chiral centers. So ang technique na sinabi ko sa inyo is that you count the number of carbons and then you deduce number 2. Since ang CHO and the CH2OH here are not chiral. So we determined that already. And then it means the only chiral center here is in the second carbon. So for aldotriose yon. So we have n equal to 1. So you just um, substitute 1 from this formula, 2 raised to 1, then that gives you 2 possible stereoisomers. So we did this for your 4 carbons, your 5 carbons, and then for your 6 carbon atoms. So for this morning, we'll be talking about new things or new concepts about carbohydrates. So to start, we have this term called epimers. So epimers are sugars that differ in configuration in only one chiral center. So aside from the penultimate carbon. So may cases kasi na yung mga structure natin na makikita natin na nagkakaiba lang sila in a particular chiral center. For example, this one, D-mannose and D-glucose are both epimers. So why do we say that mannose and glucose are epimers? Simply because if we will look at the carbon 3 and carbon 4 ni mannose and glucose, they are the same. Okay? So we don't consider anymore the penultimate carbon, the carbon number 5. So nakikita nyo dito, your in mannose and glucose, it's in the OH group is in the left and right respectively for carbon 3 and carbon number 4. Do sa carbon 2, ang difference lang nila ay ito. Yung OH group ni mannose ay nasa left while your glucose is on the right. So we can say that D-mannose and D-glucose are C2 epimers. Yan. So this one are C2 epimers. We say set C2 epimers meaning they only differ in the carbon 2 position. Okay? This one, the OH, the position of the OH. One is in the left for mannose and then the OH group for the glucose and the carbon 2 is on the right. On the other hand naman, D-glucose and D-galactose are also epimers of each other. So, as you can see, they are also uh, they are also epimers in a sense that they have the same configuration or orientation do sa carbon number 2, same orientation with carbon number 3, yung OH groups. Ayan. So, ito, OH, both on the right for carbon 2, both on the left, dun sa carbon number 3. And here comes the difference. In carbon number 4, the OH group for glucose is on the right, while the OH group for galactose is on the left. So, we can say that your glucose and galactose are both epimers also, but in the C4 position. So, carbon number 4 epimers, ang glucose and the galactose. Okay? So, they are medyo, when you say epimers, they have roughly the same structure, chemical structure, but they only differ in one chiral center, in one carbon. Okay? Now, we will be talking about cyclization of monosaccharide. So when we do cyclic structures, this is drawn using Hayward projection. So yung Hayward projection natin ay yun yung may makikita kayong parang pentagon later on. Okay? So, in drawing your Hayward projection, you should take note the orientation. Okay? Later on, magiging mahalaga ito na alam nyo ito. So, if your if the OH is on the left, then later on, pag dinowing natin yung Hayward, this OH in the third position will be up. So, naka-up siya. And then, yung OH natin na nasa right will be drawn on the downside siya. Okay? So, up, left, right, down. Okay? So, ito mga to, yung OH na yan, mamaya, idodrawing natin siya na nasa ilalim. So, paano natin idodrawing? So, this one is your we call this your Fisher, di ba? Fisher projection. Then, this one is your Hayward. So, take note of the take note of the orientation. So, yung ating OH, ito, in carbon position number 2, ito ay nasa ilalim. So, that's why it is here, down. Down, up, down, and ito, OH, ay may mahalaga siyang role na paano na gagawin in the cyclization. When say cyclization, magko-close ring siya. Okay? So, kaya ito ay down, up, down. So, for carbon number 2 and 2, 3, 4, so it should be down, up, down. So, ito ay down, up, down. Okay? So, ganyan yung mangyayari. And then, yung OH na to, ito kasi yung mag-react with the C double bond O. It will attack this OH will attack the anomeric carbon. And then, yung CH2OH na to ay ito naman ang nasa taas. Ito. Nasa taas ito lagi. Ayan. In carbon number 6. Okay? So, the OH group in the carbon position number 5, dun sa ating penultimate carbon, this will attack the anomeric carbon. Okay? So, when this attacks the anomeric carbon, the oxygen will be bonded to C. What will happen now to what will now happen to your oxygen kasi will react with will react with itself. The OH will react with the C. So, may ma-form kayong bond between the O and the C. Ito na yan. Okay? Now, kung mapapansin nyo, magiging sobra yung bond ni carbon. So, that's why this C double bond O should be broken. May isang mababawasan dyan. So, itong si oxygen, ito ay electrons yan. So, magiging negative siya dyan. Now, remember, meron tayong naalis na H dito. So, itong H na to will be bonded to the oxygen here. Okay? So, it will be bonded to the hydrogen here. So, that will become OH. Okay? So, bakit squiggly? So, yun yung process. So, bakit naging squiggly line ito? Kasi, yung OH dito can either be on top, kumbaga, on top of the plane siya. So, pwede siyang maging ganyan, o kaya naman ay pababa siya. Okay? So, that's why we represent it with a curvy line. Okay? So, that is the process on how your Fisher projection will be turned into a Hayward projection for glucose. So, magkakaroon naman tayo ulit ng isa pang klase ng stereoisomer, and we call this an anomer. So, anomer is defined as a stereoisomer that differ in the configuration at the anomeric carbon. So, we have two types of anomers. The first one is an alpha anomer and the other one is a beta anomer. So, when say alpha anomer, it is down. The OH is down. Ano ba yung ibig sabihin ng down? Imagine nyo that this is a plane. This one is a plane. Yan. If this is a plane, itong si H2OH, itong OH dun sa carbon number 3, these are above the plane. So, ito namang OH group ng second carbon and fourth carbon ay below the plane. So, yung sinasabi ko sa inyo kanina na pag yung OH ay nasa taas, then we call this your beta. And then, kapag nasa baba naman yung OH, nasa baba, nasa baba, ganyan, this will become your alpha anomer. So, ang tandaan nyo dito is beta up, alpha down. Okay? Beta up, alpha down. Okay? So, ito yung sinasabi ko sa inyo kanina. Possible kasi na yung OH natin, yan, yung OH will be below the plane. So, this will become an alpha glucose. Pero we will give it a special name now. It's an alpha D because we know that sugars are naturally occurring as D in the configuration. And then this one is a gluco. This is glucose. And when we have a six-membered ring, with the oxygen being part of that ring, we call that a pyranose. Okay? So, ito namang isa is kapag yung ating OH group ay nasa taas. So, this one is called your beta D glucopyranose. Okay? So, beta up, this is up, and then alpha down. So, tatandaan nyo yung anomers na yan. So, for the case naman ng isang ketohexose like fructose, so ano naman ang magkakaroon ng reaction? So, the OH here, the OH in the penultimate carbon natin in fructose will attack this one. The OH will attack the anomeric carbon. Okay? And same goes dun sa same reaction ay mangyayari. Okay. So, tandaan nga natin that anything on the left will be situated on the upper portion and then yung ating right ay nasa down. Kaya itong OH na to OH in the fourth carbon is drawn sa ilalim. Okay? This is down. Yan. And then, yun namang ating carbon position number 3 ay naka-up naman ito. So, this one is up. Okay. Now, the O, again, same scenario. The oxygen will attack the anomeric carbon. So, there will be a bond formation. So, maaalis yung H. Okay. So, O will be bonded to C. There will be an excess bond around carbon. So, that's why the oxygen here will get the excess bond and it will become negative. Yung dalawang electrons dyan will make it negative here. Now, to remember na may H tayong naalis, so that H can now attach dito sa portion ng O. So, it will become also an OH group. So, yung palang carbon number 1 natin and carbon number 6 natin ay same siya, CH2OH. So, itong dalawang ito naman ay, yan, yung carbon number 6 natin ay nasa taas. Ito, this is up. Okay, up yan. Lagi nasa taas yan. And then, ito namang CH2OH ng ating carbon number 1 can either be below or up. Kasi nga, meron tayo mapo-form na OH. So, for D-fructose na magiging cyclic, This time, we will call it naman a furanose. So, a five-membered ring with oxygen, ang tawag natin dyan is a furanose. So, five-membered ring. So, yung ating CH2OH and OH in the carbon position number, this is now carbon position number 2, ay mag-iiba siya. So, may dalawang scenario. The OH group is, ito ay below. So, that's why this is an alpha. This is down. 'Di ba? Down, nasa ilalim siya. Puwede din naman yung OH natin ay nasa taas, so this will become your beta. Okay? So what will be the right name for this uh, cyclic version ng ating fructose? So it will become, this one is an alpha fructofuranose. And then if you have the OH group above the plane, ayan, above siya. So this will become beta fructofuranose. So this one is your linear, and then this is your two possible cyclic structure. Okay? And we determine the two possible anomers. One is an alpha and the other one is a beta anomer. So, ito bang anomers natin alpha and beta ay exclusive lang ba siya na alpha lang siya and then beta lang siya? Ang nangyayari kasi dito class ay yung ating alpha and beta anomers natin ay it can interconvert. So, if for example you have an alpha anomer, it should undergo first a linear form. So, kumbaga, yung inyong cyclic structure, bubukas ulit siya, and then it will become a linear one in the linear form. Then, it will undergo a reaction in which your uh, mapo-form natin yung beta anomer. So, this process in which your anomers are interconverted to each other, we call this your mutarotation. So, it can also start from beta naman, then it will open the chain. Ito, yung ating structure dito, cyclic structure will open for a while and then it will again close into an alpha D anomer. Okay? So that process is called mutarotation. So, now that you have already discussed the whereabouts for monosaccharide, then now's the time to discuss naman your disaccharides. So again, disaccharides consist of two monosaccharide units. These are linked by a glycosidic bond. So kung sa peptides natin, it is amino acids are connected via a peptide bond. Then in disaccharides, polysaccharides, and oligosaccharides, then the bond is called a glycosidic bond. So I will show some of the notable disaccharides natin. So the first one natin is called lactose. So lactose is actually made up of two monosaccharides. So the first one is beta galactose, and the other one is a alpha D glucose. So this is already in the cyclic form. So that's why we will assign it as a pyridose. So what will be the reaction? So the OH ito, so the OH in the carbon position number 1 will react with the OH of the carbon number 4 of glucose. So, ano ang mangyayari dyan? So, what will happen here is actually may maaalis tayong water. So, laging ganun yung nangyayari sa mga organic reactions natin na meron tayong nare-release na water. So, this OH and the H here will be released. And then, your glycosidic bond is formed here. And the glycosidic bond is from 1 to 4. So if we will give a systematic name for lactose, it will become an O because the glycosidic bond kasi natin is linked in an O. Yan, sa oxygen. So yung ating starting natin is the beta-D-galactopyranosyl. So yung itong pyranose natin dito, we will make this ill. Kaya siya naging galactopyranosyl. Then, itong makikita nyo 1,4, this means that uh, yung nag-react is yung or nag-connect is yung carbon 1 to carbon number 4 of what? The glucopyranose. So, this one naman is your alpha D glucopyranose. So, if you will read the systematic name for lactose, it will become O beta D galactopyranosyl 1,4 alpha D glucopyranose. So, that is the systematic name for lactose. On the other hand naman, we have your maltose. So, maltose is a combination of two glucose units. So, specifically, this is alpha D glucopyranose. So, what will be the reaction? So, the reaction will be between the OH in the carbon number 1 and the OH of the carbon number 4 of the other glucose units. So, ganun din, same yung mangyayari. Meron tayong maaalis na water dyan. So, after maalis yung water, ay mapo-form naman natin yung alpha 1,4 glycosidic bond. So, bakit siya naging alpha 1,4? Because the orientation nung nung ating bond kasi ay going down. So, itong OH kasi dito is, yan, pareha silang alpha. So, this one is alpha, this bond here is alpha 1,4 glycosidic bond. So, if we will assign a systematic name for maltose, it will become O, meaning the glycosidic bond is through an oxygen. So, O alpha D glucopyranosyl 1,4 alpha D glucopyranose. Okay. So, ito naman yung inyong very familiar kayo is the sucrose. So, sucrose naman natin is a combination of an alpha D glucose and a beta D fructose. So, yung glucose natin dito is 6-membered and then yung fructose naman natin is 5-membered. Kaya yung isa ay ina-assign natin siya na pyranose because we have the 6-membered ring including the oxygen and then furanose for a 5-membered ring kasama yung oxygen in that particular ring. So, what will be the reaction? So, the reaction will be between the OH in carbon number 1 in the glucose and the OH in the OH attached in the second carbon. Okay. So, again, may maaalis tayo dyan na water and then the glycosidic bond will be formed. Kaya, the connection between the two monosaccharide is between an oxygen atom. So, the alpha 1 and the beta 2, yung alpha 1 natin, kasi di ba down ito, this one is alpha, and then ito naman is yung beta. So, the beta in carbon position 2, and then the alpha in position number 1. So, yung bond na mapo-form natin is alpha 1, beta 2, glycosidic bond. So, if we will assign a systematic name for this, it will become oxygen O O-alpha D glucopyranosyl 1,2 beta D uh, fructopyranoside. Okay? So it will become like that. So ang mahalaga lang dito, don't worry, hindi naman masyadong mahalaga 'tong systematic name na 'to. All you need to remember is the bond between the the two monosaccharides. Again, for lactose, it's alpha. This one is this one is beta 1, beta 1 to alpha 4. Yon. So beta 1, alpha 4 for lactose. For maltose, it's an alpha 1,4 glycosidic bond. And then for sucrose, ito naman ay yung bond is between the alpha 1 and the beta 2 glycosidic bond. Now, for polysaccharides, these are consist of 10 to thousands of monosaccharide units. And this can be homopolymers or heteropolymers. When say homopolymers, it is made up of only one type of monosaccharide. But if you have a heteropolymer, you have a combination of two or more monosaccharides. For example, meron tong glucose and then there's mannose. So if you have that connections, uh, glucose and mannose, glucose or galactose, then we call it a heteropolymer. For cellulose, this is made up of n number of glucose. So napakadami niyan, and the bonding is between beta 1,4. So beta 1,4. So beta kasi yung ating uh, this one is the carbon 1. So beta up siya and then nakakonect siya dun sa 4 nung susunod na glucose unit. So cellulose is the one responsible for the cell wall ng ating plants. So, yung ating cellulose kasi is actually made up of microfibril and then there's cellulose molecules. Ayan. So, string yan. So, imagine a very long string of glucose and that will form your cellulose. On the other hand naman, we have your starch. So, starch is made out of two uh, two components. The first one is an amylose. This accounts for 10 to 20%, and the bond is an alpha 1,4. So if this is the first, ito yung first ano natin na glucose unit natin. So the connection between the two glucose unit is via an alpha 1,4. So alpha siya kasi this one is originally down. Yan. Yan. So, down yan. So, kasi di ba tandaan natin na beta up, alpha down. So, yung position dito, yan. Yung carbon 1 natin, yung OH is originally down and then na-form yung glycosidic bond between the carbon 1 and carbon number 4. So, that is called an alpha 1,4 glycosidic bond. So, ano naman yung isa pang component ng ating starch? We call that your amylopectin. So, this accounts naman for 80 to 90% of our starch. So, meron lang kakaiba dito sa amylopectin because your glucose units are still connected via the alpha 1,4 glycosidic bond. Pero meron imagine nyo, you have strings of glucose, dapat meron tayong tinatawag na branching. So, yung branching naman dito is between an alpha 1,6 glycosidic bond. So, for example, this is your glucose. Para ma-form yung branch, kasi yung amylopectin is the branch component of your starch. Para magkaroon ng branching, dapat magkaroon muna ng bond between the alpha 16. Ano ibig sabihin ng alpha 16? Ito kasi is, if we will count this is your carbon 6. This is carbon 1, 2, 3, 4, 5, 6. So, itong carbon dito, originally, that is CH2OH. So, itong O dyan is, dyan din nagkaroon ng site ng glycosidic bond. Yan. So, itong OH na to, yan, the OH here, reacted dun sa OH dito sa, yan, yung naka-down. So, ito ay naka-down, ito naman ay naka-up. So, nagkaroon ng glycosidic bond between the carbon number 1 and the carbon number 6 natin. So, that's why ang na-form natin is an alpha 16 glycosidic bond. So, yung amylopectin natin ay makikita natin siya in every 24 to 30 residue. So, for example, imagine you have a string of glucose units natin. Pagdating sa 24th na unit ng glucose, doon magkakaroon ng branching. Okay? So, doon magkakaroon ng branching. So, ano ang significance ng branching? Kasi class, kung ang ating starch ay linear lang, tuloy-tuloy lang siya, parang magiging kamukha siya ng cellulose. So, at yung pagbabranch kasi is an efficient way of storage ng ating starch. Kaya, um, kung natatandaan nyo sa photosynthesis, ang chloroplast napakaliit lang pero nasa-store doon yung starch efficiently kasi nga because of this degree of branching. Now, we have also another type of polysaccharide. This time, this is called your glycogen. So, yung similar siya dun sa starch natin. We also have your alpha 14 and the alpha 16. The difference lang is the degree of branching. So, the degree of branching for glycogen is every 8 to 12. If you will compare it with starch, it is 24 to 30. So, count again. So, you have a string of glucose units connected to each other. Dun sa pang 8 hanggang dun sa pang 12, doon nag-o-occur yung branching natin. So, yun yung dalawang main difference ng ating starch and glycogen. And we can also make another comparison nilang dalawa is yung sa kung saan ba siya nasa-store. So, starch is rather a plant. Starch is a plant polysaccharide. Yan. So, polysaccharide siya na nasa-store sa ating starch. So, ito siguro 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yan. So, 24. Ito, yan, yung mga hexagon dyan is representing the glucose. So, in the 24th na glucose unit, doon na nagkakaroon ng branching. And that branch can also have its own what? Linear sequence or sequence ng ating ng glucose. So, for glycogen naman, which is the animal polysaccharide, ang degree of branching naman is every 8. So, if we will count, let's refer to this one. So, 1, 2, 3, 4, 5, 6. Or sabihin natin ito ay, dito lang tayo mag-start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, sabi nga natin 8 to 10. So, this is the 10th position. So, nagkaroon ng branch and then nagkaroon ulit ng connection ng glucose. Yan. Then, maybe this is 8 to 10, then another branch. So, talagang yung storage ng glucose in glycogen form is very efficient. Okay? And, yung ating kasing mga starch and glycogen, kapag tinignan nyo talaga siya, it's actually in a crystalline form. So, crystalline siya. So, we owe the crystalline structure of starch because of this branching. And same goes with glycogen. So, for the last part of this topic will be on digestion of carbohydrates. So, mabilis na lang ito. Saan ba nangyayari yung digestion of carbohydrates? So, mainly, the digestion happens in the mouth and in the small intestine. So, in the mouth, ito yung ating mechanical grinding. So, we crunch our food, di ba? Kaya nga, mahalaga daw ng ginunguya ng maayos yung ating food. So, it will mechanically. And then, also, in our mouth, di ba, we have your salivary glands. So, your salivary glands, you excrete here your saliva, and that saliva contains an, um, an enzyme called amylase. So the amylase will be responsible for the initial breakdown, aside from the mechanical breakdown of your grinding nung sa teeth nyo. Yan. So na-breakdown natin into smaller chunk yung ating uh, food. And also, it happens in the small intestine. So saan naman nangyayari yung absorption? So the absorption mainly occurs in the small intestine. So for your mouth, you have your salivary amylase. So your polysaccharides are being degraded into its oligosaccharides. So yung polysaccharide nga, ito yung tens to hundreds of our monosaccharides. And then you have your oligosaccharides. We chop them into smaller, um, smaller length. Then it will go to your uh, stomach, and then in your this one is ano na uh, sa brush border na to. So sa jejunum na to, yan after kasi nito ay small intestine na siya. Yan. So the small intestine, some monosaccharides are absorbed now. Yung iba naman na hindi pa ma-absorb ay will further be degraded in the small intestine. So, in the small intestine natin, ito yung scenario. In the intestinal lumen natin, yung ating mga starch like amylose and amylopectin and dextrine and oligosaccharides are being acted upon by your amylase and dextrinase. Okay? Starch is being degraded by amylase. And yung dextrine natin, it is degraded by dextrinase. Now, in the brush border natin, if you already have your sucrose, which is a disaccharide, then you need your sucrase to further break it down into fructose and glucose. So, itong free fructose and free glucose natin, this will be now readily absorbed. For lactose naman, 'di ba, in our discussion of lactose intolerance, your lactase is usually not present. So if that's the case, then you have lactose intolerance. So if in your lactose, it is acted upon by lactase, and that will give you glucose and then galactose. For maltose, you have a glucosidase. So glucosidase yung name for uh, the enzyme. So it will give you 2 units of glucose. So this glucose I will enter now ito dun sa ating mga enterocytes. So via this Na plus glucose co-transporter. So, may pumapasok na sodium plus, and then may pumapasok din na glucose. And kasama doon na pumapasok din yung galactose. Yung fructose, meron siyang sariling transporter. Yan. So, may sarili siyang transporter. Okay? So, yan. And then, meron ulit na transport protein naman. We call this yung GLUT2. So, glucose transporter 2 ay siya naman yung ito, yung galactose and glucose natin, palalabasin niya, and then it will go to the basolateral side, and then adjacent to it is a blood vessel. So, your glucose and galactose will be free now na makapunta na dun sa mga areas ng ating body sa cells natin na kailangan ng cellular energy. And same goes with your fructose. There is also a transporter nun palabas nung ating palabas ng this is actually the small intestine pa nga to eh. So dun sa blood vessel, maipapadala na o maisasabay na sa blood yung ating mga monosaccharides, glucose, galactose, and your fructose. Pero the problem there is your galactose and your fructose are not the usual forms of of source of energy. So this galactose and fructose will be first converted to glucose. Yan. And kapag may glucose na, doon pa lang tayo magsa-start ng process ng degradation ng glucose for giving you energy, and that will be glycolysis. So that topic will be covered in our next topic. Okay? So, for today, ang mga napag-usapan natin ay yung inyong epimers having nagdi-differ lang sila in one carbon. So, the notable epimers natin ay mannose and glucose and galactose. So, I also shown you the cyclization reaction of monosaccharides, and this time you have your Hayward projection. So, tandaan na kapag nasa left yung inyong OH, it will be drawn up, nasa taas. And then if your OH is on the right, then you will draw it down. So this one is the cyclization reaction, and because of this cyclization reaction, it will give you two possible orientation of the OH in the carbon position number 1 in the anomeric carbon natin. So one is on up, and then the other one is on a down, down yung setup niya. So we call this beta up, and then yung sa ay alpha down. Yan. So tandaan, these are anomers. So I also shown you the cyclization for a fructose. So that will give you a 5-membered ring, and you call this your furanose. For 6-membered ring, including the oxygen, you call that your pyranose. Okay? And the interconversion of these anomers it is possible because of mutarotation. So for disaccharides, these are two monosaccharide units bonded through a glycosidic bond. We mentioned lactose, maltose, and sucrose. By the way, I forgot pala. So we have this here a term reducing disaccharide, meaning to say that yung isa doon sa inyong monosaccharide has a free anomeric carbon pa siya. So this one, for the part of lactose dun sa glucose, ito, free pa yung inyong anomeric carbon dito. So, this will react. Meron tayong tinatawag na Benedict's reagent. And then, I will show this in the laboratory. And that will give you a red color. So, the disaccharide, when you subject it with Benedict's test, it will give you a red color. And that will give you an indication that it's a reducing disaccharide. Same goes with maltose because you have a free here, anomeric carbon. But for your sucrose, 'di ba, yung OH dun sa anomeric carbon in carbon number 2 for fructose and the OH in the glucose, itong mga to ay nagamit siya. Nagamit siya for the reaction. So this one is called a non-reducing disaccharide. We also mentioned polysaccharides. It can be 10 to thousands of monosaccharide units. It could be homopolymer if it's made of one monosaccharide only. If it's heteropolymer, then you have a combination of 2 or more monosaccharides. But it is in madami siya. Okay. So we mentioned cellulose having a beta-1,4 glycosidic bond, and this is responsible for the cell wall of our plants. We have also starch linked by alpha 1,4. It is made up of two components, your amylose, which accounts for 10 to 20, and then amylopectin is 80 to 90. So the same lang naman yung bonding, pero the sa amylopectin, you have this branching, which is alpha 1,6. And it occurs in 24 to 30. For glycogen, same scenario with starch, but the difference lang is the degree of branching. It's every 8 to 12. And I have mentioned the difference. I highlighted the difference between starch and glycogen based on the degree of branching and the source ng ating polysaccharides na to. And I also mentioned the digestion process of carbohydrates. So that's it. And thank you very much.